My name's Maher. I am Senior Lead Engineer, 25 plus years, in oil and gas industry, decoding the physics and economics of energy in my channel from hydrocarbons to nuclear fusion. We provide the technical clarity students and pros need. Welcome back to Energy Decoded. Episode 2, The Kitchen. In our first session, we explored the deposition of organic matter in anoxic environments. Today we go deep underground to explore the geological kitchen, the extreme natural refining process that converts biological waste into high-density liquid energy. This transformation is driven by two fundamental physical parameters, pressure and heat. The process begins at the bottom of an anoxic sea. Here, dead phytoplankton and zooplankton are preserved in oxygen-poor mud, forming the source rock's organic base. But dead plankton is not fuel. It must be cooked under precise conditions of depth, temperature and geological time to reach its full potential. As tectonic subsidence and continuous sedimentation pile thousands of meters of new rock on top, we enter the stage of diagenesis. The weight of this massive overburden creates immense lithostatic pressure, physically crushing the source rock. This pressure is the first stage of the natural refinery. The physics of this burial is governed by the law P equals ROGH. As depth increases, the density and gravitational weight of the overlying rock reduce the source rock's porosity from 40% to near zero. This expels water and consolidates the organic sludge into a complex, waxy polymer known as kerogen. Not all kerogen is equal. Marine-derived type 2. Kerogen is our primary source for liquid oil, while type 3, from terrestrial plants, tends to generate natural gas. However, to trigger any chemical conversion, we require a thermal driver to overcome the carbon-carbon bond strength. As our source rock is pushed deeper into the crust, it is subjected to the Earth's geothermal gradient. On average, the temperature increases by 25 to 30 degrees Celsius for every kilometre of burial. This rising heat provides the activation energy required to break the strong molecular bonds within the kerogen polymer. Between depths of roughly 2 to 4 kilometres, the rock reaches the critical thermal range of 60 to 120 degrees Celsius. We call this regime the oil window. Here we enter catagenesis, a kinetic reaction where thermal energy finally overcomes the activation energy barrier. This cracking is governed by the Arrhenius equation. As temperature T rises, the rate of thermal cracking K increases exponentially. The massive kerogen molecules fracture into the shorter, liquid hydrocarbon chains we recognize as crude oil. The kitchen is now producing liquid energy. Inside the microscopic pores of the shale, golden droplets of liquid oil form. But if the Earth's crust continues to subside, the source rock is pushed even deeper. Past 4 kilometers, temperatures exceed 120 degrees Celsius, and the environment becomes too hostile for liquid oil to remain stable. We enter the gas window. The long hydrocarbon chains undergo secondary cracking, breaking down even further into the simplest, lightest molecule possible, methane or natural gas. This higher temperature regime, up to 200 degrees Celsius, marks the final stage of hydrocarbon generation. This chemical conversion creates a profound physical problem: volume expansion. When solid kerogen turns into liquid and gas, the fluid volume expands significantly. The newly generated hydrocarbons require more space than the original solid matrix could provide, creating intense internal overpressure. When this internal pressure exceeds the mechanical strength of the source rock, it causes the impermeable shale to fracture. These microfractures allow the oil and gas to be violently expelled. We call this explosive event primary migration. The oil is finally free. The kitchen has done its work, but the journey toward a commercial reservoir has just begun. In our next session, we will decode the fluid mechanics of episode 3, Migration Physics. I am Maher, and this is Energy Decoded, from black gold to blue power.